Hello, pre-calculus students. In our last few videos, we've been working with different types of identities. Today, we're going to have some new ones, and we call them the sum and difference identities for sine and cosine. Here's the information that we need to derive those identities. Well, we need the distance formula. You already know that. You don't know the law of cosines because in the textbook that we're using as I make this video, we're in chapter 5. We don't get the law of cosines till chapter 6, FRL. Alrighty, so we'll have to use that for now. We have to know something about odd and even functions. F of negative x equals negative f of x for odd functions, and f of negative x equals f of x for even functions. And we also need to know this. And this should be pretty easy to prove if you draw a right triangle in the first quadrant. You should be able to prove that pretty easily. So let's start with the law of cosines that we'll get next chapter. The law of cosines, I call it the Pythagorean theorem for non-right triangles. You'll see it's a squared plus b squared equals c squared. And that's great if big C here is a right angle. If big C is not a right angle, we have to subtract 2ab cosine C. And you see that if C is a right angle, cosine C is 0. So it does simplify to the Pythagorean theorem. So you see that we have if we know side A, side B, and angle C, we can get side C. So this is a side angle side situation. So here's the formula that we need. And as I said, we don't know that law of cosines yet, except for what I just showed you. We'll derive it next chapter, but we're going to use it now to derive the sum and difference identities for sine, cosine, and tangent. Make that as big as I can for you. Now, here's starting, we have our ray in standard position along the positive x-axis. We rotate it through angle B, and the coordinates of this point, assuming this is a unit circle, are cosine B, sine B. We then continue rotating it, so A again starts in standard position, and we rotate alpha A, beta B. We rotate all the way over to here. That's angle alpha, and its coordinates are cosine alpha, sine alpha, right here. So what is the measure of this green angle? You should be able to answer that to yourself. What is this green angle's measure? Well, if this was B and this whole thing was A, this must be A minus B. And again, here are the coordinates of this point and the coordinates of this point. So what's this distance? Well, let's find that distance squared, and we can take the square root of it. And we're going to find that distance squared using the law of cosines. So if you go back to how I drew the picture before, the opposite side is AB. Side A is 1, side B is 1 because they're both radii of the unit circle. And there's cosine of A minus B. Alrighty, so there's the length squared. Actually, we're not going to take the square root because now we're going to use the distance formula and find AB squared. And then we'll set this formula equal to the distance formula. So distance formula says x2 minus x1 quantity squared, y2 minus y1 quantity squared. We're not going to take the square root because we're just going to leave it squared. FOIL this, combine like terms, and we end up with this expression. I encourage you to go through that in detail. Make sure that you understand that. So when we did the law of cosines, we got this formula. When we did, and that's here, when we did the distance formula, we got this formula, which is here. Well, we can get rid of these 2's right away, and we can divide these negative 2's out. Oops. And here's a formula. So the cosine of the difference of two angles is this. And if you want to know what cosine of A plus B is, well, we know that if you replace B with negative B, that would be cosine of A plus negative B, or A minus B. Cosine of negative B is cosine B. That's our even function. Sine of negative B is negative sine B. And here's our formula then for the cosine of A plus B. And the way we write it is like this. We'd say A plus or minus B, and we'd say this minus or plus this. In other words, if we want A plus B, if we want the top function over here, it's cosine cosine minus sine sine, because it's the top sine over here. We use the minus over here, which is the bottom sine. We'd use the plus over here, which is the bottom sine. This way we can write two formulas at once because we math people are lazy. All right, and how about the identity for sine? Well, as I pointed out, we should know this. We should be able to figure this out pretty easily. Or you can use the what we just determined, the law of the sum and difference identities for cosine, in this case, the sum identity. And if you get some, do some substitutions, you'll end up with this formula. So here it's plus or minus, over here it's plus or minus. And again, writing these down is not sufficient. You should follow each step of these derivations to make sure that you understand them. All right, tangent of A plus B is sine A plus B over cosine A plus B. And we get this expression. Then we're going to divide the top and bottom by cosine A cosine B. Well, if we divide this expression here by cosine A cosine B, the cosine B's will cancel. You have sine A over sine B, which is tangent A. Cosine A divide this by cosine A cosine B. The cosine A's will cancel. You'll have sine B over sine B, tangent B. Cosine A cosine B divided by that is 1. Sine A sine B divided by cosine A cosine B, you'd have tangent A tangent B. And then because tangent is an odd function, if you replace B with negative B, tangent of negative B is negative tangent of B. So that negative tangent of B would make this a plus. And here's our difference identity for tangent. So I kind of threw at you the law of cosines. You have to take my word for it right now. But we've now derived 3 new identities. They are always true because, well, then sine and cosine are always true. Tangent's true wherever tangent is defined. So as I said, drawing a picture, we should be able to tell that sine of 90 degrees minus x is equal to cosine x. But let's try it with a formula. So here's the formula for sine of, some books use a minus b, some use u minus v, doesn't matter. So here's our formula. So u is 90 degrees, v is x. So I'm going to substitute 90 degrees here, x here, 90 degrees here, x here. Sine of 90 degrees is 1, cosine of 90 degrees is 0. Yeah, and we've shown using the formula what we could tell by doing a drawing. We also know that if you take an angle plus 2 pi, you're going to get a coterminal angle. So the sine of x plus 2 pi should be the same as the sine of x. So we're going to let u be x and v be 2 pi. U is x, v is 2 pi, u is x, v is 2 pi. Cosine of 2 pi is 1, sine of 2 pi is 0, and we do end up with sine x, which is just what we thought we should end up with. Now I'm just going to let you copy this. We'll go over this in class. So let's say I have an angle U, which is in the first quadrant, and an angle V, which is in the first quadrant. All I know about angle U is that its sine is 2/3, and it's in the first quadrant. And all I know about angle V is that its sine is 1/7, and it's in second quadrant, my bad, second quadrant. So if we were to add angles U and V, what would the cosine of that angle be? Well, here's our formula. Cosine of U plus V is cosine U, cosine V minus, if you look back at your notes, sine U, sine V. Well, I need cosine U and cosine V. I know sine U and sine V. Well, if I know the sine, I can find the cosine using the Pythagorean identity. So sine squared u, sine of u is 2/3, so sine squared of u is 4/9. Some of you will make a mistake and write the sine of 4/9 or sine squared of 4/9 and then not know what to do with that. If the sine of u is 2/3, we're going to square both sides of this. We just end up with 4/9, not the sine of 4/9. And the cosine of u is going to be plus or minus √5/3. But since it's a first quadrant angle, it's positive √5/3. And similarly, if I know the sine of v is 1/7, I can get the cosine of v is 4 plus or minus 4√3/7. And because it's a second quadrant angle, I know the cosine has to be negative. So now we have sine u, sine v, cosine v. We can substitute them into this formula here. At this point, some will again make the mistake. They'll write cosine of √5/3. No, the cosine of u isn't, well, u is an angle. The cosine of that angle is √5/3. We're not going to take a cosine of a cosine. That doesn't mean anything. So cosine of u is √5/3. Cosine of v is negative 4√3/7 minus sine of u is 2/3. Sine of v is 1/7. And we end up with this expression. Notice that I never did find out what angle U and angle V are. Didn't care. What I cared about was what was the cosine of their sum. So if I were to take this first quadrant angle and this second quadrant angle, Obviously, the sum of them is either going to be a second or third quadrant angle. Think about why that is. And then, so the cosine of the second or third quadrant angle is going to be negative, and sure enough, we came up with a very negative number. You know, I just said the cosine of a cosine doesn't make any sense. But here we're going to take the sine of an arctangent, and that does make sense because back here, when I said taking the cosine of a cosine, the cosine of an angle is a ratio. You don't take, and then if to take the cosine of that again, you don't take the cosine of a ratio, you take the cosine of an angle. Well, the arctangent of a ratio is an angle. Arccosine of a ratio is an angle. Add these two angles, you get an angle, and you can take the sine of an angle. All right, so I'm going to let this be U and this be V. So U is arctangent of 1. And what I did is I drew a right triangle here. This is 1 and this is 1, then 1 over 1 would be my tangent. This is root 2. So this is angle U right here. And you can see that U has a tangent of 1. Arc cosine of X, well, cosine, if this is X and this is 1, angle V here has an arc cosine of X over 1, or X, which would make this side over here the square root of 1 minus X squared. All right, so the sine of this angle plus this angle, sine of U is 1 over root 2, which is root 2 over 2. Yes, I expect you to rationalize denominators and simplify fractions in the end. Cosine of V is X over 1, or X. Cosine of U is 1 over root 2, which is root 2 over 2. Sine of V, opposite over adjacent, Y over R, square root of 1 minus X squared over 1. Then I just factored out the root 2 because it looked prettier. So whatever X is, and X has to be a number between 0 and 1, or negative 1 and 1, in order to get a value here, this is going to be your answer. So to summarize, here are the two formulas, the two sum and difference formulas for cosine and sine. We'll hold off on tangent even though we've already derived it. Remember, if you use the plus over here, the top function, you'll use the plus over here, which is the top function. If you use the bottom, which is the minus, you'll use the bottom and the minus. Over in the cosine, the top function over here is plus, over here is minus. The bottom function over here is minus, this is plus. I am not going to have you memorize these. There's no sense in that. These are identities that I think it's okay to look up. So that should have been plenty fun. Let's talk about this in class. Have a great day.